All right, so we're gonna get started with 1.6 linear systems. So the essential question is, how do you solve a system of linear equations graphically? When it comes to algebra 2, we're gonna be using technology a lot, specifically your calculator. So in algebra 1, we learned how to solve systems of equations graphically by substitution and elimination. Today, I'm gonna show you how to do this graphically using your calculator, which is how I want you to do from now on. So take this for example, and there's one thing that I want you to take into account when it comes to a system of equation. When you're solving an equation, you're solving for one variable, you're solving for X. When you're solving a system, you're solving for X and Y. You're solving for the whole point, okay? We're still gonna look for the intersection, but you're looking for the whole point. All right. We're gonna go ahead and graph the equations. Now, they're not in graphing mode, they're actually in standard form, which means that we need to rearrange them so they look like y equals mx plus b. All right, well, let's go ahead and do that individually. I'm gonna rewrite them. And then here's the other one. And because I want them in the form of y equals mx plus b, that means I need y by itself. So I need to move everything that is not y to the right side. Well, the first equation, that's pretty easy. How do I get rid of that x? Doing the opposite, which is negative x. Whatever I do to one side, I'm going to go ahead and do to the other. And let's just go ahead and do the math. X minus x equals 0. So that's gone. I'm left with 2y equals 3 minus x. Now, those are not like terms, which means we can't take 3 and subtract an x. It's like taking an apple and subtracting an orange. That's not possible. So what we're going to do is we're actually just going to leave them the way they are. We're just going to rewrite them. And I want to rewrite the x first. So this is going to look like negative x. And then that 3 is positive. So I'm just going to write it as plus 3. All right, we're almost done. I still need to get rid of that 2. I know that the 2 and the y are multiplying each other. So to do the opposite of multiplication, I need to divide by 2. And I'm going to divide everything by 2. All right, I'm going to draw my line and then just do the math. 2 divided by 2 equals 1. So I'm left with y equals, now notice what's going to happen. I know there's no number in front of the x, but technically there's a 1. Now, if I divide that, I'm going to get negative 1 divided by 2, which is negative 0.5. I do not want a decimal as my slope because I want my slope in the form of rise over run. So if it's in the decimal form, I'm not going to know which one is the rise and I'm not going to know which one is the run. So I'm just going to rewrite negative 1 over 2x the same thing or the same way. Negative 1 over 2x. And then I got 3 divided by 2, which also gets me a fraction, but because we're going to be using the calculator, I'm just going to rewrite 3 over 2. I know 3 over 2 is 1.5. You can write 1.5 if you want to, but I'm just not going to do it. All right, the second one, same thing. I got to get the y by itself. So opposite of x, it's negative x. So I'm going to subtract x to both sides. I'm going to draw the line, and x minus x equals 0. I'm going to drop negative 2y equals, and again, just like the other problem, 4 minus x, they're not like terms. So I'm just going to rewrite them by writing the x first. Last step, I'm going to divide. What is the opposite of multiplying by negative 2? That would be dividing by negative 2. So I'm going to divide everything by negative 2. I'm going to draw my line and let's do the math. Negative 2 divided by negative 2 equals 1. So I'm left with y equals, and then same thing. What's in front of the x? Well, there's technically a 1. So I got negative 1 divided by negative 2. Well, that's going to give me 0.5. Again, I don't want a decimal, so I'm just going to leave it as a fraction. However, you do have a negative divided by a negative, so that actually becomes a positive. So I'm just going to rewrite that as 1/2 x. And then I got 4 divided by negative 2. That actually gets me a whole number. So I'm just going to rewrite that as negative 2. So I got my two equations. So what I'm gonna do is I'm gonna grab my calculator and do this on the calculator. All right, so now that you're on your calculator, let's go ahead and graph it. So I'm gonna go to y equals, and I'm gonna input my first equation. So that's gonna be negative alpha y, enter 1 divided by 2, x plus alpha y, enter, and then I got 3 divided by 2. So that's my first equation. On the second one, I'm gonna write 1/2 x minus 2. So alpha y, enter 1 divided by 2, x minus 2. So those are my two equations. I'm gonna go ahead and graph them. And you can see that there's an intersection right there. Well, how do I find that intersection specifically? I need to click on second trace, and I'm gonna tell my calculator that I wanna find the intersection. So that is 5. I'm gonna click enter, and I'm gonna move that flashy dot or star to the right side, and I'm gonna put it right on the intersection and click enter 3 times. And I can see that my intersection is happening at x equals 3.5 and y equals negative 0.25. All right, so that means that my answer is x equals 3.5 and y equals negative 0.25. So like I said earlier, the difference between solving an equation and solving a system is that an equation only has an x value. We're looking for the x value. A system of equations, we're looking for both the x and the y. All right, moving on. The last essential question, that is, how can you solve systems of linear inequalities? So there's a way to do this on the calculator. We're going to do that later. I'm going to show you how to do this by hand, because first we need to understand where things are coming from. Now, before we start graphing, we need to go over 2 rules. Now, the first one, when you have greater than or equal to or less than or equal to, we're going to be using a solid line when we graph the equations. If they don't have the equal sign, we're going to be using a dash line. And that means that no value is included within that dash line. The other set of rules is, that's the first one. If you have y is greater than or equal to, it doesn't really matter. You're going to be shading the top. And if you have y is less than or equal to or less than, you're going to be shading the bottom. All right, so have those 2 rules in mind. So let's go ahead and graph these inequalities, and you're going to be graphing them just like any equation. So I'm going to graph the first one using black. And it is in the form of y equals mx plus b. It's just switched over, which means that the y-intercept is 20. So I'm going to write my y-intercept at 20. And then the slope is -2, which means it's -2 over 1. So I'm going to go down 2 over 1, and I'm just going to find a bunch of points. And let's go through the rules. Well, I have greater than or equal to, which means I'm going to be drawing this with a solid line. And it's greater than, which means I'm going to be shading the top. The top of that line. Cool. Second equation, I'm going to use red. And same thing. My y-intercept is at 20, which means they have the same starting point. And my slope is -1 over 1. So that means I'm going to go down 1 over 1 and then just find a bunch of points. And let's go ahead and look at the rules. So the rules say that because it has an equal sign, I'm going to be using a solid line. And it's less than, which means that I'm going to be shading the bottom part of the line. Only the bottom part of the red line. And then I got one more. I'm gonna be using this colorful bluish purple. Y is greater than or equal to 5. Well, it doesn't have a slope, which means it's gonna be a constant line, and it's gonna be a constant line at 5. So at 5, I'm gonna make a line, and notice that it says equal to, which means we're gonna be using a solid line. And it wants me to shade. It says Y is greater than, which means it wants me to shade the top part of that line, and that's gonna be this top part. And what you want to be looking for is the overlap of all the lines. I know some of them are overlapping twice, but there's one little area that is overlapping 3 times. Notice that this middle area has both, or has the red line, the black line, and also the purple one, which means that all of the lines overlap on that little area, which means that this area is the solution to the inequality. So when it comes to an inequality, you are looking for the area. So there isn't just one answer. There's a bunch of answers. So any point that is inside that area is a solution. So for example, 10,6, that is right there. That is one of the solutions to the inequality.